Welcome back, Geometry. I'm picking up where I left off on that first video. So number 7 through 9 is interesting. What they're doing is they're saying, here are some variable expressions for some unknown angles. And what we're doing is we're basically forcing the two lines to be parallel with the value of x that makes them parallel. So what we're doing is we're using this list over here of things to say, each one of these has to be true about parallel lines. So when we look at something like number 7, what equation must we come up with if we're forcing line P and line Q to be parallel? Well, we're saying that the angle 3x and the angle 45 must be congruent if they are to be parallel, because these are the corresponding angles in this little diagram here, and corresponding angles are congruent. So because they're corresponding angles, you would set 3x equal to 45. Yeah, and to solve that equation, just divide by 3, x equals to 15. You're done. That's it. Okay, number 8. What's the relationship between 2x plus 10, this angle right here, and the 120-degree angle that exists here? Upper left, lower left, lower left, lower right, upper right, upper right. They're corresponding angles too. So corresponding angles are congruent. So you're just setting those equal to each other. And solving that equation the best way you know how. X equals 55. Now I'm going to add something here because I feel like this note sheet is kind of shallow. It doesn't give you any deeper examples. So on number 9, I'm going to throw something at you. I'm going to say that, yeah, this is 2x plus 20 for sure, but I'm also going to state that this angle right here is 2y. So I'm going to solve for both y and x in this situation. Now, if we forget about the 2y for a moment, you should be able to recognize that 80 and 2x plus 20, this angle here and that angle there, have a special relationship. They're alternate interior angles. And because we're forcing those two lines to be parallel, you know that they are congruent. It's number 2 on the list. So what you're going to do is set 80 equal to 2x plus 20. And then solve the equation from there. So you can subtract 20 from both sides. 60 equals 2x. Then divide by 2. Hey, x equals 30. You get your first angle. Sorry, you didn't see that. My bad. So now, the question is, let's just pretend like I didn't have that 2x plus 20 in there. Let's just pretend like the only thing that matters is the 2y right there. What's the relationship between 80 and 2y? Consecutive angles. These would be consecutive angles. 80 and 2y are consecutive angles. Consecutive interior, which means they add up to 180. They're supplementary. So that's what you would do if you encountered that situation on the homework. If you encountered back-to-back angles inside here, you'd say 80 plus 2y must equal 180. And then you'd solve the equation like normal. All right, so that y equaling 100 divided by 2, 50, forces these two lines to be parallel because consecutive interior angles are always supplementary when two lines are parallel. Awesome. Moving right along. All right, so we're given the diagram. Determine which lines are parallel if we know that angle 13 and 11 are congruent. This is going to be a little tricky. It might mess with your brain a little bit. So, what they're saying is, hey, we know that 13 and 11 must be congruent. Okay? These two are congruent. So what does that mean? Well, it means that alternate exterior angles are congruent, which means that the two lines that are parallel are the ones that were formed when you cut it with this Q transversal right here. So if angle 13 and 11 are the same, then you have to say that angle M and angle L are congruent. Sorry, not congruent, parallel. Angle M is parallel to angle L. We don't know if angle N and Q are parallel with just this information. In order for N and Q to be proven parallel, you'd need more information. That's it for number 10. Number 11. We've got 4 and 8. The relationship between 4 and 8 is that they are corresponding angles. They're lower left of these two right here. So think about it. I've got these two lines. This transversal creates two angles from these two lines. So which ones are parallel? It's got to be M and L again. What happens when 16 and 2 are shown to be congruent? Well, here's 16, and here's 2. Again, alternate exterior angles when M crosses through N and Q creates this congruent statement. So you could completely ignore all of this right here. You could completely ignore line L, and this information should point us to the fact that these two lines are parallel. N is parallel to Q. All right, and then the last one, they're telling us that angle 7 and angle 9 are the same. Well, these are inside N and Q, and they're catty-corner. They're basically diagonals. So I could ignore line M in this situation, and it would show that N and Q are still parallel to one another because alternate interior angles are congruent when the two lines that they're created by are parallel. All right. Now, I'm not going to ask you guys to do any proofs on the homework, but I thought it'd be beneficial for you guys to see one done on the video here. So check this out. They're saying angle 1 is congruent to angle 2 as a given statement. So whenever you have to write a proof, if they give it to you, you're using that to set the stage so that there's a common truth between the writer and the reader of the proof. So why does angle 1 have to be congruent to angle 3? Well, the angles are across from each other. Isn't there a name for that? Oh, they're vertical angles. Vertical? Actually, here's what you do. When you write the proof, you say vertical angles are congruent. Because that's a true statement always. Yeah. Well, why would angle 2 have to be congruent to angle 3? Here's angle 3. Is there a reason why this one and that one have to be the same measure? Well, yeah. Wait. I don't want to jump the gun on this. Oh, sorry. That was fun, wasn't it? Angle 1 is congruent to angle 2. Angle 1 is congruent to angle 3. Therefore, angle 2 is congruent to angle 3. If they both equal angle 1, if they both are congruent to angle 1, then they should be congruent to each other. That's called the transitive property for congruence. I don't know if you guys have ever heard that before. A lot of times somebody will use the transitive property in sports. They'll say something like, well, if the Bulls beat the Knicks and the Knicks beat the Lakers, the Bulls will then beat the Lakers. That's kind of like the transitive property, which doesn't really work when you talk about real life situations like that. But it's the transitive property for congruence. And if that's the case, by the way, if angle 2 and angle 3 are the same, then they're corresponding angles. So if corresponding angles are congruent, then that's when you have parallel lines. All right, guys. Sorry, that was a really clunky way of explaining that proof. Just because we're remote, I'm not going to touch the proofs until we come back in person. If corresponding angles are congruent, then they force the two lines to be parallel. All right. I'm going to quit while I don't know if I'm ahead right now. I'm just going to quit at this point with the video. I think you guys got enough information to at least thoughtfully work your way through 5.3b and 5.3c. Thanks for watching.